Hello, welcome to Backer Breaks It Down. This is a special episode. Yes, we are looking at similarity in right triangles, but we're going to take a look at a problem that has a little bit more algebra in it than we are accustomed to, okay? So just to remind you, basically these problems involve us taking a right triangle and drawing in the altitude going from like the vertex of the right angle to the hypotenuse. And what this does is it divides the triangle into two smaller right triangles, and all three triangles are similar to one another. And so we discovered that the altitude, which is h, is the geometric mean between the segments of the hypotenuse. So simply put, h over x equals y over h. We discovered that the leg, so A and B, is the geometric mean between the segment adjacent to the leg and the hypotenuse. So for leg A, we have A over C equals X over A. And for leg B, we have B over C equals Y over B. Okay. And then also, don't forget, this says X plus Y equals C. X and Y are the segments of your hypotenuse. C is the whole hypotenuse. Okay. So we have not yet looked at example number 3. Because like I have there, warning, algebra, like there's quite a bit of algebra here. And so let's take a look at what do we know. Let's assess the situation. All right. So I can label my diagram using those 6 parts. So I could be like leg A, leg B, the hypotenuse is C, A and X go together, B and Y go together, and then the altitude is H. Okay, and so what I realize is that I know leg A, I know segment Y, and I want to find, well, I'm calling it X. So one thing I need to realize is segment X plus segment Y is equal to the hypotenuse of C. So I can say in this problem that C, the hypotenuse, is equal to X plus 21. And that's going to be helpful here because I know that the leg is the geometric mean between the hypotenuse and its adjacent segment. Okay, so I can write that proportionally as like leg A over the hypotenuse C is equal to the adjacent segment, which is X over A. That's what this comes from, okay? So let me throw our values into our geometric mean proportion here. So leg A is 10. The hypotenuse is X plus 21. The adjacent segment is X, and the leg is 10. So here's my initial proportion. So now I'm going to do that cross multiplying. So I'm going to go 10 times 10 is 100, and I'm going to go X plus 21 times X. So I'm going to write it like this first, okay, because I have to be careful here. I need to make sure that I distribute the X. So X times X is X squared, and X times 21 is 21X. So this is where we're at right now, okay. 100 equals X squared plus 21X. This is a quadratic equation, okay, and I can solve quadratic equations by factoring and using the zero product property. The first thing that I must do, though, before I can factor is I have to get this equation equal to 0. So I need to subtract 100 from both sides. So now I have 0 equals X squared plus 21X minus 100. So once my quadratic equation is equal to 0, then I can go ahead and I can factor it. Okay, and this one's easy. Like I do need to think what multiplies to be like negative 100 that adds to be 21. Okay, so negative 100 is the constant term, 21 is that middle term, and I can organize this in a cute little X box. So this right here is the hardest part of factoring, is trying to find these two factors, what multiplies to be negative 100 and adds to be positive 21. Okay, if I go 4 times 25, this will give me 100. It has to be negative 100, so that means one of these is negative. Since I want them to add to be positive 21, the 4 should be negative, because the negative 4 plus 25 is 21. Okay, so now I can write out my factored form, right? So I'm going to have one of my factors is going to be x and then the minus 4, okay, because of this one. And the other factor is going to be x plus 25, because positive 25 was one of my factors, okay? And then here I want to do something called the zero product property, ZPP. And the zero product property is where I take the factor and I set it equal to 0 and I solve for x, which can probably be done mentally with these two factors, okay? But still, I'm just kind of showing you what I am doing in my head, because I know that you can't read my mind. At least I hope you can. Okay. So algebraically, I have two solutions here. I have x is equal to 4, and I have x is equal to negative 25. This being geometry, x is representing the length of a segment. So we have to be like, well, what makes sense? Okay. And negative 25 doesn't make sense for the length of a segment. 4 does. And so 4 is our answer here. Okay. So I'm still using the similar right triangle rules to set up this problem. It's just that after I found my cross products, it produced a quadratic equation. So to solve a quadratic equation, get it equal to 0, factor, and then use the zero product property to find the values of x. And then, of course, ask yourself, what makes sense? Because this is geometry. And that's how Becker breaks it down.